So I've gone live as well on YouTube, and if any of you prefer to watch it on there, the link is in the event. Hello again.
Hello again.
Let me just finish this. So I'm just doing one very quick thing for the intro. I was asked to do this as a favor. Let's see if anybody else wants to join. Okay, view. I'll just share my screen on the slideshow. Okay, I'll just put on the slideshow. Hello, Lee. Thanks for joining. How are you? Lee's Lee Hawkins, and he's actually speaking in the next talk.
Hi, Lee.
Hi, Paul. Let me put my camera on. Hey,
how are you?
Hello.
Good.
It's going to be mentioned in the intro anyway, but you and Ashley, Lee and Ashley Graff are doing the next talk, or the next two talks, which will be on the 12th of April. We're originally going to do it in person, but we're going to do it online because it's it clashes with school holidays here in Sydney.
It looks like you're stalking me a little, Lee.
He's just a big fan.
So I think it was for the testing tribe. So I did a talk, and then I saw all this stuff about you doing a talk there as well.
Yeah. I was just one step behind those.
It's nice being ahead for a change. So,
Indeed.
Well, we're all big stands of you. What can I say? And welcome to Matt as well, who is who's on the Sydney Testers committee. He's spoken at Sydney Testers a couple of times as well. Hello, Matt. How are you?
Hi, Paul. I'm well, thanks. Hi, Ben.
Hey.
Hey.
How you doing?
Yeah, good thing.
Cool. So we're about to start in about 5 or 10 minutes, as soon as people come in, and then I'll show the slides. We do the intro. But I might just share the screen now, actually. So I might have to do it like this, actually, because it doesn't show up on the Zoom. Let me just change this, actually. Okay, there's 2 people as well following us on YouTube. Thank you. Let me know if you've got any problems hearing us, because we have had some problems with the audio on YouTube. So if you have any problems with the YouTube, please let me know in the comments. I'll be monitoring the chat, the actual YouTube chat. I'll be monitoring that over the course of the event, as I will the Zoom. First of all, the meetup has kind of started, although we're giving it a few minutes to allow more people to come in. We'll start in about 5 minutes. This is the kind of schedule we have, although we're probably running a bit like 5 minutes early. We are recording. We haven't started the recording yet, but I will be recording this. So if any of you are a bit concerned about that, I'm sorry. This is just for the, this is just so we can post it afterwards. I'll just see if there's any comments in the chat. Oh, Andres Markuson says, "Good morning, all. Best wishes from Denmark." Thank you. If you've got any comments, just post them in the meeting chat. And we haven't started yet. I'll read them out. We will be doing a question and answer session at the end, so people can, pose any new questions. If you can, Baz, what do you prefer to do? Do you prefer to take questions on the go, or do you want to wait till wait for all the questions to be at the end?
What's easiest for you? I don't really have a preference. So I'm Dutch, so I'm used to being interrupted all the time. That's what we do. So
we Brits can be.
I'm fine either way.
Okay, all right. Thank you. Well, in that case, if there are any questions, I'll pose them to you, and then you can tell me if it's interrupting you.
Sure, sounds good.
Okay, cool. Thank you. Let me just check. Okay, there's a few more people coming in. So I've got 34 people in the chat, 3 people watching on YouTube currently. Sorry, 34 people on Zoom, including us, obviously. 3 people watching on YouTube. As I said, if there's any problems on the YouTube, particularly with the sound, please let me know. I can read the comments. Jithin Muncie just wrote, "Let's go Dutch then." I like that. All right, 2 more minutes and we'll start. Oh, sure.
Sounds good.
Everyone, it says 4:45 or 45 minutes past the hour here, 15 minutes past the hour if you're in India. We'll actually start in a minute. I'm just checking, just finishing off the rest of the audio, seeing the rest of the setup to see if there's any problems. There aren't any. It looks good at the moment. Is that for anyone in the chat apart from Baz or Lee, or Matt? Is there any? Are there any? Sorry, is there any audio problems? Or any audio visual problems? Please let me know. Also, I've got a question from Andreas Markuson. Will you be doing where are the people from in the world? Would be nice to hear about the reach of contract testing. So yeah, please post in the meeting chat, where you are from, where you're watching this from. And I'll try and go through it. So Vipin from India, Matt obviously from Sydney, Vanitha from Sydney, Prabodh from Sydney. Who else? Lots. Rena Liu from Sydney, Abdul from Sydney, Aman from Sydney, Harini from Sydney, Vic from Sydney, Alexander Zanuski from Poland, from Wocklaw, Jitin from Melbourne, Deepak from Melbourne, Fly from New Zealand, Lee, obviously you're from Victoria, Fateh from Melbourne, Nitin from Sydney, Imran from Sydney, Scott Blacklock from Sydney, Yojita from India, Virish Guri from India, Lina from Mauritius, Georgie from Hanover, Mithan from Sydney. Thank you, and you are all most welcome. Okay, we will now start. So I will put on the recording.
Recording in progress.
So let me just go to the first slide. this is it. So welcome today. My name is Paul Maxwell Walters. I am one of the committee at Sydney Testers. And this talk is by Bas Dijkstra, a friend of Sydney Testers and also a great expert in the field, improving your integration testing efforts with contract testing. So we'll be talking about contract testing today. Let me just move to the next slide. So yeah, this is kind of the workflow that we're doing, although we're 5 minutes early. So so we're about to do a little 5-minute talk, then there'll be an introduction, and then a little 5-minute introduction, and then Bas will start his talk, and then we'll have a Q&A session at the end. So who are we? We're Sydney Testers. We're a group of volunteers with a focus on improving testing in Sydney. We organise monthly talks, socials, and other events for the Sydney testing community. We had a wide range of international speakers, including Michael Bolton, James Barks, Zoe Tibbett, Sam Connolly, Jean Ann Harrison, Trish Koo, Richard Bradshaw, Matt Santon Rutherford, who's here today, Rich Rogers, Stephanie Russell, Milan Kaur, Manoj Kumar, who spoke last month or at the beginning of this month. We are looking for people to help out, so on the exec. So if you're interested, get in touch with me, paul@gmail.com. Okay, so moving on. So tonight's speaker is Bas Dijkstra. This is his second talk. I think it's your second talk, isn't it? As Sydney Testers.
It is, yeah.
Yeah, it is. And you're an internationally known test automation consultant and trainer, active in this field for 16 years. Worked on software testing and automation solutions across a wide range of programming languages, frameworks, and technology stacks. Delivered test automation training to dozens of companies and hundreds of conference attendees in the Netherlands and abroad to excellent reviews. And you can be found at ontestingautomation.com, great website. I've had a look at it myself. And linkedin.com for Bas Dijkstra. Do you still have a Twitter, or have you finished that?
I finished that, I think, almost 4 years ago now. So no.
Okay, right, no. Yeah. I wanted to check that.
Yeah, I've been off it for a while. So I still get the odd person linking to what used to be my profile, but there's no point.
Okay, hold on. There's a few more people for me to add. Scott Miles, Ogi Avuz, actually loads of people have just so yeah. So this is just Bas Dijkstra. He's speaking tonight on contract testing. A little a little write about him. And next, in 2 weeks' time, we have Ashley Graff and Lee Hawkins. They'll be doing 2 talks online on the 12th of April. And Ashley Graff is talking briefly about how to onboard new testers. Lee, do you want to talk briefly about what your talk's going to be about?
Putting me on the spot there. Yes, I can remember what my talk's about. I think my talk is going to be
lessons learned in software testing.
Lessons learned in software testing. So it's not a review of the book of the same name, but it's just me sharing a few of the lessons I've learned over the last 25 years doing this stuff. Okay. For the benefit of your audience. So yeah, that's what I'm going to be talking about.
Okay, cool. Thank you. And I'll be posting an event for that this evening, and on Meetup and on LinkedIn. So what I need, that's the final slide. So what I need to do is to stop the screen share here and share the screen back to stop my own screen share, sorry. So Bas, it's all yours.
Thank you so much, Paul. Can you please once again confirm that you can see my screen.
I can. I just got to do it manually for the people who are on YouTube. But now we can see your screen.
Awesome. So thank you again for having me, Paul, and for the invitation. Thank you to everybody who's listening live, either here in the Zoom session or through YouTube, for taking the time out of your day. I was going to say good morning, but it's not good morning for most of it. Well, I hope it is good day for most of you, but it's definitely not morning anymore for most of you. But then thanks again for taking the time out of your day to join us here at Sydney Testers. I'm not going to talk too much about myself. Paul did a wonderful. I know there's no way I can top that. So
you're too kind.
I'm just going to start. I'm just starting. I'll just start talking about what you came here for, and which is contract testing. So why contract testing? Because I think it's first of all, I think it's a very interesting technology, very interesting technique, which can bring lots of benefits for teams and organizations looking to improve their testing and automation efforts in distributed and microservices-based systems. It's over the last, so I've been reading about and working with contract testing for a couple of years now, and in those last couple of years, I've definitely seen demand for experience and for knowledge, expertise. That's the word I was looking for. Expertise in contract testing growing, and it doesn't seem to slow down. So it's I see that in demand for workshops. I see that in the number of people who sign up for talks on contract testing. I see that in just general content that you see all over the internet. It's a bit of a hot topic. So I thought it would be nice to share with you my take on contract testing, talk a little bit about the problems that it's supposed to solve, because I think that's always more interesting than just talk about the technique. And I'll give you a bit of a live demo on 2 different approaches to contract testing. So this is the and once more, my apologies for my horrible slide design. Much like most of my brain, it's still very much stuck in the 1990s. So I apologize for that. But this is the situation that a lot of organizations are in right now. And they used to build monolithic software, and they're looking to to improve flexibility, to make it easier to do deployments, to make it easier to distribute work across teams and departments and organizations. They're looking towards migrating towards a more distributed software architecture. Whether or not you call that microservices, that's, well, you could call it microservices. Some teams who claim they do microservices don't really do microservices, but good news is contract testing, it's often associated with pure microservices based architectures, but it works pretty well in any distributed software architecture. So it doesn't necessarily have to be microservices, because, well, no, I don't think we've agreed on what's a microservice and yet. So but don't worry about that and about the terminology too much. So this is the move that a lot of organizations are making or are looking to make. And of course, as I said, that has a lot of, they do that with the intention of bringing a lot of introducing, well, benefits, distributed software development, and being able to develop different components in parallel, because they live in separate repositories, and they're deployed and managed individually. And if done well, that's absolutely true. You get that, you get those benefits. You get the ability to just deploy or swap out or update an individual component without having to redeploy the entire application, and with all the effort that takes and all the things that can go wrong there. So people see a lot of benefit, but there's a couple of things that become harder. But one of the most important things that definitely becomes harder is for us as testers, because at the more distributed our software system becomes, the more difficult it becomes to get a proper good answer to this question. Are all individual components and services able to communicate with one another? With a monolithic software system, it's just, well, you have one component, that's your system. So you'll see soon enough if there are any problems in communication there. With distributed software systems, you have all these different individual components developed by different teams, each team developing and deploying at their own pace, at their own frequency, at their own heartbeat. And integration and end-to-end testing becomes difficult, and managing the ability and just being able to do proper integration and end-to-end testing becomes more difficult, because, well, there's one component that's still under development, and the other one is we're suffering from there's a bug, and there's a national holiday for yet another team. And so the puzzle of being able to do integration and end-to-end testing becomes more difficult the more distributed your system becomes. The traditional approach to integration and end-to-end testing has always been to try and test what I call everything at once. So conjure up a test environment and frantically try and scramble to get a version of all of the components that play a role in those tests into that test environment in some kind of known state. So configuration, data, all those kinds of things. And then try and do integration testing as best as you can. The problem is it's you're always shooting at a very rapidly moving target here. I've seen teams, organizations where just managing the test environment and making sure that we can do some form of integration and testing is a full-time role for a team of people. I don't think that's necessarily the best situation to be in, and it's definitely not the most fun situation to be in. And this is where contract-based testing comes in. It's an approach, a technique supported by tools that is aiming to solve this, to address this problem. And it's fundamentally different from traditional integration and end-to-end testing approaches in two ways. First of all, instead of focusing on everything at once, on the integration of everything at once, it focuses on the integration of individual consumer and provider pairs. So instead of checking, are A, B, C, and D able to communicate with one another, it checks, is A able to talk to B, is B able to talk to C, and is B able to talk to D in this case. So it breaks down that puzzle of integration testing into smaller, much more manageable pieces. So, and it does the way that works specifically and how contracts play a role in this. We'll get to that in a moment. But for now, please keep this picture in mind, that contract-based, it breaks down this puzzle by focusing on individual integrations. The other big difference is that traditional means of integration end-to-end testing are synchronous, meaning if I want to test that component A is able to communicate with component B, they both have to be in some sort of testing environment, actually communicating live with one another at some point in time. Requests are actually flying from A to B, and responses are flying back from B to A. And again, that means that these components need to be in some kind of shared test environment at some point in time. And again, the more components you've got, the more difficult that possibly becomes. Contract-based integration and end-to-end testing is asynchronous, meaning that there's contract-based testing removes the requirement for separate components to share a test environment at some point in time. Sure, the consumer and the provider still play a role, have their responsibilities in the process, but they can do that as part of their own development and deployment cycle, as within their own pipeline, so to say, which makes contract-based integration and end-to-end testing. I don't really like the term, but it's a shift left, so to say, what people refer to as a shift left, because you're able to do integration and end-to-end testing a lot earlier in the process, because you can do that, or at least your part of the process as a consumer or as a provider, as part of your own development cycle. It's all local instead of having to wait until you can do that kind of testing in some sort of shared test environment. So let's look at an example. We'll look at the code later on, because I've got a live demo with some code. But let's say, for example, we're running a web shop and we have some different services there. So we have a service that's responsible for managing data for around customers, another service that manages data around orders, and they both rely on address service. From a customer, from that customer service perspective, they might have expectations. They do, and they will have expectations about the behavior of the provider. So, for example, what happens when I create a new address on the address provider? How does the address provider behave in that situation? What happens if I do a get, if I retrieve address data? What happens if I try to delete address data? In the examples, you'll see expectations around the get and the delete. The concept is the same no matter what operation you use. So, for example, in the examples, you'll see what happens if I try to retrieve an address where the address ID is formatted correctly and there's data in the address provider. In that case, I'll probably expect an HTTP 200 and data in some shape. If the address ID is correctly formatted, but there's no data, I'll expect a 404. And if the address ID is specified incorrectly or formatted incorrectly, I'll expect an HTTP 400, for example, a bad request response. And so that's the kind of expectations that we're talking about when we're talking about contract testing. So there's a couple of different approaches to contract testing. What people talk about most in contract testing is consumer-driven contract testing, or CDCT, because that's the most popular form of contract testing at the moment. It's not the only approach, and when there's multiple approaches, you can be absolutely sure that some approaches will work better in some situations, whereas other approaches work better in other situations. So it's something I see a lot of people when they say, well, we're going to do contract testing, they immediately jump to consumer-driven contract testing, because that's where that's the space where the most popular tools are working in. But there's different approaches to contract testing. What you're going to see in the first step of the demo is consumer-driven contract testing. But there's also provider-driven contract testing, obviously, and there's bidirectional contract testing. And I'm not going to talk about provider-driven contract testing, but I am going to talk about bidirectional contract testing as well. And you'll see that in action too. But let's focus on consumer-driven contract testing, or CDCT, first. So again, that's a technique supported by tools that can help us formalize the expectations that consumers have about the behavior of the provider in contracts. Again, it's called consumer-driven contract testing because it's the consumer who's in the lead. They are in charge of, well, dear provider, these are my expectations. Please let me know if you can fulfill them. With consumer-driven contract testing, the consumer creates contracts containing their expectations. Again, it's good to know that a contract is an agreement between a single consumer and a single provider. So if a provider is consumed by 5 consumers and they all do consumer-driven contract testing, the provider needs to prove that they can adhere, that they can fulfill expectations in 5 different contracts, which also means there can be conflicts of interest. The tools that support CDCT allow you to obviously automatically check that expectations are met. One of the biggest benefits, I think, for providers is that they can develop and refactor without fear, because sure, they'll probably, hopefully, have their own set of tests which verify the behavior of a component against their own expectations. But now with consumer-driven contract, they also have input, they have expectations about how the consumers expect them to behave. So as long as they can demonstrate that they can meet the expectations that are written down by the consumer, they can basically do whatever they want. They can upgrade frameworks, write new code, delete code, completely rewrite their code. And as long as they fulfill the expectations in the contracts, there should not be an integration issue. Should not be. And of course, it's also a great way for the consumers to build trust in their providers, because they have insights into the latest status. I think we're talking distributed software development here. So maybe the provider that you rely on as a consumer is developed in a different team, in a different organization, on a different continent. I don't know. With contract-based testing, you have some sort of reassurance that providers can keep working. So it's easier to trust what they are doing. The way Pact works, which is the tool that we're going to look at, and one of the most popular tools for contract-based testing, is, well, obviously it all starts with the consumer. They generate a contract containing their expectations about the behavior of a provider. That contract is then also used to generate a mock provider, which behaves exactly as the actual provider is expected to, which the consumer itself can then use to verify their own implementation. The contract is obviously then distributed to the provider, and the provider can, on the provider side, Pact generates a mock consumer that invokes the actual provider, checks that the responses returned by the actual provider meet the expectations in the contract, and publishes the results on that. That's in a nutshell how this flow works. So in admittedly a very ugly diagram, we have a consumer, we have a provider, and we have a broker. The Pact broker is a central repository for contracts and contract verification results. You'll see that Pact broker in the demo as well. So what the typical flow looks like is we have a consumer who generates a contract containing expectations about the behavior of the provider, publishes that contract to a broker. The provider then downloads the contract and verifies its implementation against the expectations. It publishes the verification results, and then as a final step in the development and deployment process, both the consumer and the provider can query the Pact broker for verification results to check, well, is it safe to deploy? And the tool that does that in the Pact ecosystem is called Can I Deploy, which is why you see Can I Deploy written down here. But that's basically what the consumer-driven contract testing flow looks like. But rather than just talking about that and seeing that in a slide, let's have a look at what that looks like in code. So I've got a little project here, and by the way, all this code is available on GitHub. So if you want to have a look or a play around with it yourself, you can always. I'll show the link to the GitHub repository in a moment, but it's there so you can check it out for yourself. So this little project has 3 services in there, 2 consumers that both rely on the same provider. So customer service, an order service, and or both consumers, and an address provider service. Again, the flow starts on the consumer side. So I've got some tests here that contain expectations about the behavior of the provider. So for example, in case of HTTP GETs to retrieve data, in case the address ID exists, I expect a response with a status code 200 and a response body that looks like this. So I expect a UUID field to be in there, or an ID field to be in there that's shaped like a UUID. I expect an address type to be in there that's shaped like a string, and so on for all these fields. Now, it's important to make that distinction between the shape of the response and the actual values, because once you start asserting on actual values in the response, you're testing the logic of the provider and not just the shape of the responses, which means that you're probably crossing a boundary into functional testing of the provider. And that's not the responsibility of contract testing. That should have been done by the provider development team itself. And which is also to say that contract testing is something you do next to what people call functional testing. It's not something you do instead of functional. And so this doing contract testing doesn't relieve consumers or providers from testing their own work. This is purely meant as a technique to help you do integration testing more easily. So in case of an existing address ID, we have some expectations about the status code as well as about the shape of the response payload. And we have two other situations for the non-existent address ID and for an incorrectly formatted address ID, where we just have an expectation about the status code that the provider returns. If we run the tests on the consumer side, and again, this can be done as part of your local development deployment life cycle on the consumer side. So this is not talking to an actual provider instance. As part of these tests, they check the implementation of the customer consumer itself, but they also generate a contract containing all of the expectations that the customer and the consumer has about the behavior of the provider. So, for example, if I do a get with the address is incorrectly formatted, I expect a status code 400, and this is the most extensive one, where there's an existing address on the provider side. Then I expect a status code 200, but also, for example, an ID field that matches this regular expression, which matches the structure of a UUID, for example. I can then, and the next step is to publish that contract to a broker. This is my broker. I'm using Pact Flow as a broker, so it's good to know that there are two flavors of Pact brokers. This is a full disclaimer. This is a commercially licensed broker. I'm on the free plan, so there is a free plan, which of course has its limitations. But this is a commercially licensed product. Alternatively, you can host your own Pact broker. The Pact broker is also available as an open source Docker command. There's an open source instance hosted that you can run yourself, and that's available as a Docker container. If I hit refresh here, I'll see that, well, there's a new contract. That contract is between my customer consumer and my address provider. It was published a minute ago. It relates, it's associated with consumer version 1.1.0.0, and it's as of yet unverified. But I can see what's inside the Pact already. So there are 5 different interactions there. Let me quickly do the same for the order consumer. Because we've got another consumer that also relies on the address provider. So again, this tests the implementation of the order consumer, and it generates a contract with the expectations that the order consumer has about the behavior of the provider. And publish that too. There we go. And we'll see a second integration here from 2 separate customers or consumers, both meant for that address provider. If we move over to the address provider side, we'll have some tests there as well. Again, for demo purposes, this is all in the same repository. In real life situations, these will be different repositories probably managed by different development teams. So I've got my contract test here. Let me change this to tell my provider to pull contracts from the broker instead of from a local folder. And when I run the tests on the provider side, forgot one thing. It always happens in live demos. So what's going to happen when I run the tests, it's going to pull the contracts relevant for this provider from the broker, verify that, spin up an actual instance of the provider, verify that that instance can fulfill all of the expectations in all of the contracts, and then publish the verification results. But it only publishes verification results if I explicitly tell it to do so. So it doesn't do that by default, but I like to live a little bit dangerously here and just say, publish them right away. And I do that by setting a flag through the command line, pack.verify.publish results is true. So this allows you, if I would set that to false, or the default is false, it would do the verifications, but not publish the results immediately. But again, I like to live a little bit dangerous. I'll just publish all the info right away. So this spins up my provider instance, checks all the interactions, all the expectations in the contract, and publish the results. And we can see that both for the order consumer and the customer consumer, everything is fine. So the address provider is able to meet all of the expectations from both the consumers, which is and this information can be used both by the consumers and the providers further on in their development, deployment, life cycle, and the pipeline, if everything is automated, to ensure that, oh, are there any known integration issues? No, then please deploy into the next environment, which may just be your production environment. Let's quickly, for the customer consumer, no, I don't want to do that, change a very simple expectation, so just the status code. So now the customer consumer has a different expectation. And let me quickly, to make it really visible, change the, let's say there's a bug fix on the consumer, and the expectation changed. If I run the tests again, those will pass because, well, nothing changed in my tests on the consumer side. So they did their own testing after the fix. Everything is all well and good. On the consumer side, let's publish the updated version of that contract. So there's new expectations here from the customer side. So now, instead of for a successful delete, they no longer expect a status code 204, but a status code 200. I've published that contract now, which means that so nothing has changed for the integration between the order consumer and the address provider, but for the customer consumer and address provider integration, there's now a new version of a contract which has not been verified yet. And if I move, oh no, that's not what I wanted to type. Let's just do that this way. And if we run the tests on the address provider side again, it's now going to verify the expectations in the updated contract. And that process will say it succeeded. But if we take a closer look at the verification results, we will see a problem there, because the implementation of the address, the current implementation of the address provider, returns a 204 for the successful delete and not a 200, which is visualized in the broker by saying, well, the verification failed, and we can even have a look at why exactly it has failed. So it expected a status code of 200 because that's the expectation that the consumer communicated about. Well, in this situation, I expect you to return a 200, but you returned a 204. And if we look at the matrix, we can even see, well, this version of the consumer, and well, it doesn't really pick up the version of the provider. I need to fix that at some point, but normally the provider version would be here as well, but this hasn't changed. And we can even see, oh, this version of a consumer and this version of a provider are compatible. And once the consumer upgraded to this version, that introduced an integration issue, because now at this version of the consumer has expectations about the behavior of the provider that the provider is unable to fulfill. And which means that you have a complete overview, not just of which consumers and which providers are able to communicate with one another, but even which versions of a consumer and which versions of a provider can communicate with one another without issues. Paul, how are we doing for time?
We're doing well. That's all right. Yeah, take as long as you need.
Ooh, that's a dangerous thing to say. No, I'll be fine. So this is the consumer-driven contract testing flow, and what the traditional, or the maybe traditional is not the best word, but this is the flow, the way a lot of people talk about when they talk about contract testing. They almost invariably talk about consumer-driven contract testing, because this is where the most popular tools are. I've done a write-up on with some blog posts on the on consumer-driven contract testing, the way it works. This is the link to the first one in that series, which has links to all of the other articles. If so, and that references the same code base, the same consumers and provider. So you can always read up on basically everything I told you so far. So consumer-driven contract testing is, I think it's a great way of, again, shifting left integration and end-to-end testing, breaking down that puzzle of doing integration and end-to-end testing in distributed software architectures, and where development is spread out across different teams, different departments, different organizations. There are some implementation challenges, though. It doesn't work everywhere, and it doesn't work in every situation. First, also, using Pact, it requires you to write tests. And you need tests to generate the contract, which obviously I'm preaching to the choir. For us as testers is a given, but, well, it's probably, we all know how this works. In real life, some people find it hard to write tests and run tests. So it requires you to write it requires you to write additional tests. Also, I've skimmed over this. We have states. So we have consumer provider. There is some consumer provider coupling here. These states that we see in the code, and that's the consumer telling the provider, I need you to be in this specific state. I need you. So there's still some dependence, some coupling between the consumer and the provider. That is to be expected. That's how consumer-driven contract testing works. But it doesn't scale very well if you have a large number of consumers that all rely on the same provider. Because you then have 10, 15, 100, maybe hundreds of different consumers all telling them, oh, you need to be in this state now, you need to be in that state now. And that doesn't scale very well. It's also pretty difficult in some sense to get provider teams on board, because it's now, well, basically as a provider development team, you're now being told by all of your consumers, well, you should do this and you should do that. And not all development teams react equally well to that. So getting those teams on board can be a bit difficult. And also getting testers on board can be difficult, because I don't really like the word technical, because we're all technical, but to do consumer-driven contract testing using Pact requires a certain level of technical expertise. So you need to not just be able to write down expectations in code, but also know how to directly invoke the source code of your services, which is something that in generally speaking, developers are more comfortable with, more used to doing than testers, which means that this form of contract test is generally more easily adopted by people who call themselves developers than by people who call themselves testers. So getting testers on board can be a little bit challenging here. And these are not just my observations, but they've been the observations from the team behind Pact and Pact Flow as well. So that's why still fairly recently they introduced a new approach to contract testing, which is called bidirectional contract testing. And bidirectional contract testing is, again, a different approach to contract testing that's supposed to, or that tries to, means to address the challenges that we just talked about. Disclaimer, immediately, bidirectional contract testing is supported only by Pact Flow, so the cloud-based, commercially licensed broker flavor. The open source Pact broker, so the one you can host yourself, that's available as a Docker container, does not support bidirectional contract testing. So this is again the consumer-driven contract testing flow. So it's the consumer who's in the lead. They say they publish the contract, and it's the provider who has to say, "Oh yes, I can do that. Yes, I can do that. No, I can't do that." The bidirectional contract testing flow works a little bit different. Is simpler. With bidirectional contract testing, both the consumer and the provider upload their own version of a contract. The consumer publishes a consumer contract, and the provider publishes a provider contract. And now it's the broker who does the verification. So it's not the provider doing the verification to see if they can meet customer or consumer expectations. It's the broker that checks both versions of a contract for compatibility. This is all, and this also explains why it's only Pact Flow that can do this and not the open source Pact broker, because that one just doesn't have that feature. So the consumer publishes a contract, the provider publishes a contract, and the broker checks for compatibility. And after that's being done, just like in the consumer-driven contract testing flow, both the consumer and the provider can check for compatibility results and check if it's safe to deploy into production. The ability for the provider to publish their own contract means that it's much easier to get provider teams on board, because they say, well, I've got my own contract already, because for the provider, it's open API specification, a Swagger specification, that can be used as a contract. In general, contracts, both for the consumer side as well as for the provider side, they can be derived from existing technology and tests, which means you can do bidirectional contract testing with packed flow without using packed. So you can use packed to generate your consumer contracts, but you can also derive these consumer contracts as well as the provider contracts from existing technology. Again, for the provider side contract can just be its open API specification, because that's a specification, that's a form of a contract about the behavior of the provider. So let's have a look at how bidirectional contract testing works. Let me quickly move to, no, that's not the right one. There we go, to a different branch. In this new branch, there's a new provider. So again, think context of a web shop. We have a payment provider. Payment provider is a public API, which, and again, with public APIs and consumer-driven contract testing do not mix. Because a public API will typically just say, well, this is what I do, you deal with it. And there's typically no opportunity for a conversation between consumer and provider about, well, I expect you to do this. Can you please look into that? With public APIs, that's typically just not something you can do. So I've got a payment provider here. I think, well, Stripe, or I don't know, whatever payment provider, you know what a payment provider is, which is consumed obviously by the order consumer, because people, well, if you place an order, you probably also require to pay for it. And the payment provider has its own contract in the form of an open API specification. The order consumer, again, I told you, with bidirectional contract testing, contracts can be derived from existing technology. One of the technologies, a library supported by packed flow, is, and by the packed ecosystem rather, is the ability to generate, I know that this should just work fine. Let me quickly, where are you, reloads projects. I've got tests here, existing tests. These could have been written by automation engineers. That looks better. Which use a library called WireMock to mock out the payment provider. So we use a simulation of the payment provider instead of communicating with the actual payment provider for integration testing purposes. And this WireMock includes a packed generator listener, which will generate a consumer side contract when I run the test from, and it will generate that contract from the actual interactions between the test and the mock of the payment provider. So if I jump back to the order consumer and run the it will run all of the tests. So the traditional consumer-driven contract tests for the integration with the address service, and the it will generate a consumer-side contract for the integration between the order consumer and the payment provider in a bidirectional testing style. But for this integration between the order consumer and the payment provider, if you look at the code more closely, you won't see packed being used here. The only thing that is used here is this packed generator, which again, from the request response pairs that go from the test to the mock of the payment provider, it will generate the contract from there. If we have a look at what's generated, we will now see, if I reload from disk, there we go. And we will now see two contracts, one between the, this is the one we saw before, between the order consumer and the address provider, but now a new one that contains the expectations that the order consumer has about the payment provider. And I can publish these as well. And if I do a refresh in my broker, we'll see a third integration between the order consumer and the payment provider, which again is generated by this version of the consumer and is as of yet unverified. And again, at that payment provider, a public API, it probably has no desire to, it'll be pretty difficult to get that to adopt a consumer-driven style of contract testing. But it's the barrier of entry is much lower for them if all you need is their existing open API specification, for example, because that can serve as it's the payment provider. Sorry, this can serve as a provider side contract. So now all we need to do, again, keeping in mind this flow, is publish that provider side contract and let the broker do the verification. And the way I'm doing that here is by posting it to Packflow, to my Pack broker, through an API call that contains this base 64 encoded string. That's just have to believe me here. That's this contract, but base 64 encoded. So this is an open API specification. It's YAML, of course, and there's some additional as some additional proof for an audit trail. You can also upload additional test results if you want to. I don't think this is even mandatory. But if I publish this to broker, my broker responses as well. This contract was generated at this point in time, and if I look at the broker again, I can see that it has been successful. It's not so in this case it's not that the provider has successfully verified the consumer contract. For bidirectional testing, it's the broker has successfully matched the consumer contract, again generated from those tests that use YAML, and the provider contract, which was the open API specification. And so instead of few packed, because we don't have packs here, we have a consumer and a provider side contract, I can have a look at the contract comparison, which is what you see in bidirectional contract testing. This is what Packflow did. So I have a consumer contract, which again is these interactions generated from the YAML tests, and the provider contract is just the API specification. And Packflow has determined that these are compatible, which means that with the information that Pactflow has, and that it has extracted from the consumer contract and the provider specification, it doesn't see any integration issues, really. Now, bidirectional contract testing, it has its benefits and its drawbacks. So the benefits are that it's easier to adopt, and because you can leverage existing tests, existing technology. The drawbacks are that the type of verifications that you can do are a little bit less rich. So it's with consumer-driven contract testing, you can be a little bit more specific about the shape of response payloads, for example. You can say, well, it needs to match this regular expression, or I want an array with exactly 17 items in there. With bidirectional contract testing, it's basically the verifications are based on data types, and that's it. So that's the limitation. But in a lot of the cases, that will be enough. And one other drawback for something is that, well, you have to use a commercially licensed product here, which is Pactflow. So again, benefits, drawbacks, that's it. There's links here if you, I don't know if you can share slides after the fact, Paul. I'm more than happy to share this slide deck.
That's fine. What
if
we can
not,
do is
this
post it in the meetup, or post as a comment on LinkedIn as well.
no, sounds good. Sounds good. I'll send them over to you. Yep. Awesome. I know, because I know there's lots. Otherwise, this would be the perfect moment to hit the print screen button to at least have them. But if you have the actual slides, it's easier to copy. This GitHub repository, again, what I promised you, contains all of the code that you saw in the demo. This specific branch also includes the bidirectional contract testing examples. The main branch just focuses on the consumer-driven contract testing situation. And that's it from me. Thank you. Before we dive into Q&A, thank you for taking the time out of your day to join us. I hope this was informative. I hope you got a slightly better idea about what contract testing is, and I think even more importantly, the types of challenges that it tries to address, as well as some information about the different styles of contract testing that you can do. So it's not just consumer driven. Right. Over to you, Paul.
Thank you so much. That was a great talk. I really appreciate that. And we're getting a few comments through, a few questions through. The first question is from Nagar. He'd like to say, if you want to categorize contract testing, would you consider it as functional testing or non-functional testing? Or is functional testing even the correct language for something like this?
That's a tricky one. And it is a tricky one because I'm not a really big fan of the classification of tests into functional and non-functional, because what we do when we write tests, we verify or we observe behavior. And if that's what people call functional behavior or performance or security, it's all behavior. But if I don't want this to be a rant about, well, you should not use that terminology. I want to answer your question. The way most people define functional or non-functional, I would categorize this as functional. It's just functional outside the scope of, does a component do or behave like it's supposed to behave, and more in the area of, are these components able to functionally communicate with one another successfully.
Okay, thank you. It's great. We've had some really nice comments. Georgie says, thank you, Baz. That was a great informative talk. Shreya says, thank you, sir. Vanitha says, great demo. Thank you. I personally really enjoyed the talk as well. I've got a question to ask. You mentioned that there were downsides, particularly to, you mentioned there were downsides, areas where it wouldn't work with respect to consumer-driven contract testing. Are there any? I mean, are the downsides between consumer-driven contract testing and bidirectional contract testing? Are they actually quite similar, or are there certain? Or does bidirectional contract testing offer a higher level of? It looks like it might offer a higher level of complexity that may make it more or less suitable for environments.
It's so. The idea behind bidirectional contract testing is that it's easier to adopt because you don't need to write all that packed code, and you can leverage existing tests and technology. So it's supposed to have a lower barrier of entry, but that comes at the expense of having less options for defining rich expectations.
Okay.
So with bidirectional contract, again, it's so for example, if I send the UUID across with bidirectional verification, it will just interpret that as a string. And any string will be okay, even if it's not shaped like a UUID. With consumer-driven contract testing, you can, for example, explicitly say, well, I expect this field to add the value for this element in the response body to match this regular expression. That's something you don't have in bidirectional verification because you can't tell packed flow. It has to deal with just the information that's in those contracts. So,
all right, thank you. I think you did address it in your talk, and I think I've missed that. I forgot it. I apologize. Praveen Kumar says, "Thank you, Baz. Great demo." We do have some questions. The first one is by Scott Miles. He asks, "Thanks for the presentation, Baz. You mentioned that contract testing shouldn't be used to replace functional testing. If you're able to enable exact matching on important fields on the contract, then why shouldn't you use it to replace your functional test suite? This should enable you to have fast UI tests as the backend is mocked, and to not require and maintain a full test environment for end-to-end tests." It's quite a long question, so it's in the
No, but it's a very reasonable question. So the actual it's a bit more nuanced than that. When I say you shouldn't do this, you shouldn't use it as a replacement for functional testing if you have a consumer and a provider who are in separate teams, because basically that's the provider saying, I'm not going to do this, that's your responsibility. If you use contract testing as a means to actively check that if, in the example that you gave, a front end and a back end for the same system are compatible, in that case, you might just use that as a replacement for functional and use it as a form of functional verification. But it gets tricky when you start talking about distributed software development where consumer and provider are developed in different teams, or because then it's just you get into that discussion about, oh, that's not my responsibility, I thought you did that, and we all know how that ends.
Yeah, I appreciate this.
So it's a bit more nuanced than that, and there are I can think of situations, and I think, Scott, you just described one perfectly where you might just use it as a replacement. Yeah.
Okay, thank you. Scott, did that answer your question?
Yeah, it did. Thank you very much.
All right, thank you.
You're welcome. Thank you.
Moving on to the next, we've got a few more questions. Moving on to the next one. Do you see bidirectional contract testing as a gateway drug to pack style CDCT, or do you see these as different animals?
That's a good. You should. I think you should ask the pack development team. Well, is this a, do you intend this as a, do you intend to, is this a gateway? In all honesty, I don't think they are. No, but then again, maybe. It's a good one, because again, a lot of it will depend on situation and context. But I think, by the way, it's a great way to just get started, and if that's and also to quickly get a lot of benefit from contract testing in general. And in a lot of situations, it will be enough to do bidirectional contract testing. So you can do contract testing with relatively low effort, and to get started with contract testing with a relatively low effort. And for a lot of teams, that will already be a lot better than doing integration testing the traditional way. If at some point you run into, well, and just the situation that is described just before, if you run into the limitations of bidirectional contract testing, it might just be the gateway drug to say, well, now I see, well, this issue or this risk cannot be covered by bidirectional contract testing, but it can be by consumer-driven contract testing. So let's adopt that, because most of the team, your organization, will already be sold on the concept of contract testing in the first place, which I think is the most important and the biggest step, the most difficult hurdle to get people on board with contract testing in general in the first place.
Okay, cool. Thank you, Andres. Are you happy with the answer to that?
Yes, I am. Thank you very much.
All right, thank you. Cheers. So
thank you, Andreas.
A few more questions and then we'll wrap up. Georgie asks, Srividya says, thanks a lot, Bas. We'll get our hands dirty going through your code.
Awesome. That's why I've published it.
Thank you. I'm looking forward to getting my hands dirty with it too, actually. Georgie's posed an interesting question, which Andres responded to as well. I'm just curious if you can write CDCT contracts by hand.
You mean directly writing the JSON files by hand?
I presume so, Georgie. Is that what you mean?
Yes, you can.
Yeah.
I don't think it's necessarily a good idea, but you can. Yes, absolutely.
Andreas wrote, jumping in if it's okay, with Patch you can use a high-level DSL-like approach to specify your contracts. And when you run your consumer pack tests, then the outcome is a packed contract that is either saved on your disk as a JSON file or uploaded to Pack Broker.
Yeah.
Okay, so next couple of questions. This is from Georgie as well. How do you do contract testing when the response shape depends on the data that is invisible to the consumer, i.e. not present in the request? I presume that if you have a Swagger file, you'd know what the data would be, wouldn't you? What the shape of the data would be, wouldn't you? Or have I got that wrong?
Well, did you know what you expect the shape of the data, the shape that the data needs to be in? So that's what you express. And so there's always the optional versus mandatory thing, which is a little bit more challenging. So that's a difficult one, in all honesty. So and maybe that's because I don't understand the question well enough.
Georgie, can you just go into the chat. And, sorry, can you just unmute yourself and just maybe rephrase the question?
Let's just skip it for now.
You sure?
Yeah.
Okay.
Thank you.
Cool. Understood.
Okay.
We'll come back to that.
Thank you.
Vanitha asks, is bidirectional contract testing any different from good old schema validation tests?
Well, it's richer than just schema. It's part of it is from a provider standpoint. In the demo that we saw, it is schema validation, but it's schema validation, not just. So I think schema validation is something that a provider team should do itself as part of their own, call it functional tests. Say, well, invoke your and see if the response that you're returning is verifying against the schema. The nice thing about, I think, contract testing in general is that you don't just verify the behavior of a provider in this case against the expectations that the provider team has, but also against the expectations that the consumer teams have about the behavior of the provider. With schema validation, this is what it is, and you don't have that conversation with consumer expectations and provider verifications. You get a richer opportunity for a dialogue, really, and also schemas are static things. They're developed once and that's it. And contract testing in general, and that applies to consumer-driven contract testing, that applies to bidirectional contract testing, is a more active, almost conversation between consumer and provider about what they want. So I definitely see this as more than just schema. Sure, the schema validation is part of it, but there's more to it than, it's a little bit more nuanced, a little bit more intricate than just the schema validation.
All right. Cool, thank you. Vanitha, did that answer your question?
Yes, thank you.
Okay, thank you.
Thanks for asking.
Thank you.
Thanks. Lee makes a nice comment. Thanks for a great talk on this important topic. This is Lee Hawkins. I'll be sharing the recording of this to with my colleagues, or with one of my recording with my colleagues, and he's looking forward to hopefully some of us being at his next Sigma Testers meetup, which is on the 12th of April. I'll be posting the event and the date and the time for that. Sorry. Andres Markussen has just said to everyone, the PACT team emphasizes that this tool should not replace conversations between provider teams and consumer teams. I have had a hard time getting this formalized, but I have had a few good experiences with this. Could you please put some words on the inter-team collaborations, especially with new teams?
Sure. And I too don't think that this should replace the conversations. I think this is a great way to drive the conversation, to start the conversation. Especially in the case, so I think one of the big benefits is that, again, if you have multiple consumers that all rely on the same provider, traditional integration testing doesn't really demonstrate any conflicts of interest. For example, with contract testing, you get everyone's, well, at least everyone who decides to participate in contract testing, you get all of those perspectives. Also, what contract testing does not do is it doesn't point fingers at, oh, the consumer is at fault or the provider is at fault. It just shows there's a mismatch between expectations and how, in the case of consumer-driven contract testing, about expectations or a difference between expectations from the consumer and the actual behavior of the provider. It doesn't point fingers. It doesn't say, well, you're to blame or you're to blame. So any signals that you get, which have a failed contract test, anything that you get is a conversation starter and definitely not a replacement for a conversation. So I definitely see this as a great way to drive the conversation rather than end it or replace it.
Yeah, I was basically more thinking about, so in practice, when you sit and have a conversation between a consumer team and a provider team on a Skype call, for instance, would you then be browsing through the relatively boring JSON files, or do you have some kind of, or do you use pack? How do you see it? How do you, because just going through boring JSON files is just a killer.
Well, I don't think you have to go, but you can. I think at some point you need to go through the verification results. So say, well, this is what this is, and at the nature of that conversation also probably changes with if there's 5 consumers that all have the same expectation that is not met by the provider, it's much more likely that the provider will change compared to when there's only one consumer. So a lot of it depends on how many consumers are impacted by a certain mismatch, for example. But well, you still need, I think there's no avoiding going through those. And I wouldn't recommend going through the JSON file. I would recommend going through the verification results, which are visualized. So what you've seen is packed flow, but they are visualized just slightly differently in the open source pack broker as well. But at some point you need to go, and the nice thing about that broker is that it's a central repository and a single source of truth for all these contracts and verification results. So I think it's a great starting point for that conversation. And yeah, but that's my take on it.
Okay, thanks very much. We just have one more question. I think that's all the questions, I think. Thank you for the great talk. This is by Alexander Zanuski. What are the alternatives to the pack tool for contract testing?
That's a good one. The one I typically point out is Spring Cloud Contract. I have no experience with Spring Cloud Contract. So the nice thing about Pact, you saw Pact in action in the Java bindings of Pact. The nice thing about Pact, which I didn't mention, is that it's cross-platform. So it's available for a multitude of programming languages. So it's available for Java, but also for Python, JavaScript, C#, Go, Ruby, and I think even PHP. And Rust as well. And I'm probably forgetting one or two, which means that you can also do contract testing between a consumer that's written in Java and a provider that's written in Go, for example, because the contract format, that JSON format, is universal. With Spring Cloud Contract, you are tied to Java and more specifically to services that are built using the Spring framework. That doesn't mean it's a worse tool. It's just that it only works within that ecosystem. Apart from those two, there are some tools that claim they do it. There are probably some other tools that are working on providing the capability to do contract testing, but Pact at the moment is very much, well, the gold standard especially in consumer-driven contract testing. It's what most people know and most people use, really.
Okay, thank you very much. Just one more final. Georgie has asked, can you use contract testing with GraphQL? Andreas has just replied in the comments with a Packflow link for that. He did make the comment that Pact is not tied to HTTP, so it can be used over things like MQTT and MQ as well.
Absolutely. So and very recently, the team behind Pact has launched. I've not looked into that myself, but the Pact plugin framework, I think it's called, and with that made Pact a lot more extensible, so you can write your own adapters for your own technology. Basically, whenever you have a system that has requests and responses, you can do contract testing around it. It doesn't have to be HTTP. It doesn't have to be just JSON. So it's become a lot more flexible because that's Andreas, you already mentioned MQTT and MQ, GraphQL, Protobuf, and there's, well, I'm probably missing a lot of stuff there as well, but it's definitely, the reach is broad. The amount of technology that can cover is much broader than just the rest over HTTP.
All right, cool. Thank you very much. That's great stuff. Georgie, that answer your question all right?
Yes, thank you.
All right, thank you. So we'll wrap it up there. But I do want to offer Bas a chance to mention any talks or events that are coming up, and also to plug anything that he wishes at the end of the talk.
I'll just keep this very brief, and I just want to say, first of all, again, thank you everybody for taking your time out of your day. I really enjoyed it, especially all of the questions. Andreas, thanks to you for being so proactive and answering some of them. I really appreciate that as well. I'm not going to plug anything specific. I just want to say, if you my website contains a list of all the talks I'm doing in the next couple of months, as well as some of the services that I provide. And if you want to get in touch, email or LinkedIn are great ways to do that too. I'm happy to continue the conversation around contract testing, around testing and automation in general, or just about, lots of different things, really. So yeah, that's it from me, Paul. Thank you.
Well, thank you. And I just want to quickly tell people that the YouTube link that was mentioned in the event and on Meetup and in LinkedIn, that records that it was live streamed to there, and that will have a recording of this talk. And the sound appears to have been good on that, so I don't need to. So that should be a good reference. In terms of anything that you wanted to, you mentioned there were some files like the slides you wish to share. What we can do is, if you can send those to me, I can put them in the LinkedIn. I can put them in the Meetup. I can also put them on the YouTube page.
Oh yeah, no, I'm more than happy. I'll send them over right away.
All right, no problems. Well, thank you so much. And can we just give Bas a nice round of applause?
Thank you so much.
It's not the easiest thing to do, online, I'm afraid. But
no. I appreciate it though. I appreciate it. Thank you so much, and thank you so much for having me, Paul, and for being a wonderful host.
Thank you. And we'll wrap it up there. Bas, can you please stay on for a little bit, just for another minute? But thank you so much, everyone, and have a great day.
Have a great day, everybody. Thank you so much.
Thank you.
Recording
Thank you.
stopped.
Thank you. Thank you so much.
Thank you.